Okay. So what we really are doing is we are looking at each vector x1, x1, x2, x3, and we look at the distance of each of these vectors x1, x2, x3 from the group representative. And so as somebody pointed out correctly yesterday, what we do is basically amongst all the representatives, what we do is we choose the nearest neighbor to x1. So in this particular diagram that you are looking at here, the nearest neighbor to x1 turns out to be z1. So what we do is we assign x1 to the cluster 1. You look at x2, then what we really are doing, x2, we look at the distance of x2 from cluster representative 1, z1, z2, z3, and then we see which is the nearest neighbor to x2 amongst all z1, z2, z3. So we look at it and then we see, okay, for x2 maybe in this particular case this z2 is the nearest neighbor. So if Z2 is the nearest neighbor for X2, then we assign this cluster 2 to X2 and so on and so forth. So that's how you can assign the clusters. So C1, C2, C100, in this particular case C capital N. How do you find out those C values? You find out those C values by computing the nearest neighbors. Okay, so that is something that we want to do. So the clustering objective, as it was listed in this next slide, is the following. So what was it? It was that you look at the data point xi and you look at the cluster representative zci and you look at the distance between xi and zci in any norm that you desire. So that distance, sum of squares of such distances and mean sum of squares of all such distances, that is nothing but jclust. That was the objective, clustering objective. And what is it that we wanted? We wanted that we want to minimize this clustering objective. So what does that mean? That means that the data points are as close to the cluster representatives as possible. And what were the free variables? The free variable is we don't know how many number of clusters are there. So K obviously is a free variable or a decision variable. Cluster assignment is also not known to us a priori. We have to do that. So C1, C2, Cn, the cluster assignment, that is also a decision variable. And after you decide how many number of clusters are there, K, you can have a choice of cluster representatives also. So what is the best choice of cluster representative, so that you will have this J cluster minimize the objective, clustering objective minimized. That is something that we want to do. So that's the optimization problem that we want to solve. And this optimization involves three different types of decision variables. So the first decision variable, particular number K, then cluster representatives. Once you know how many number of clusters are there, then you sort of choose the cluster representatives. And once you choose the cluster representatives, then after the choice of cluster representatives, you want to do the cluster assignment, cluster number assignment to each of the data points. So these three are three different types of decision variables. You can vary all of them, but what we really want to do first is we want to understand how does this clustering objective behave with respect to each of this type of different types of decision variables. So what we really want to do is the following. So what I will do is I'll first fix K. Some K I will fix. Okay, so don't ask me the question now how I fix K. I will just fix K for the time being. Once the K is fixed, then what I will do, I will sort of choose the cluster representatives. How do I choose the cluster representatives? Again, please don't ask. I will just fix it. Okay. So these first two types of decision variables I'll fix, and the only decision variable I will allow to vary is the cluster assignment. So if that is what I do, then what happens? This is pretty clear. Then I have to make this cluster assignment of K clusters to the data points. Then again, you go back to this diagram, and from this diagram, what we discussed just some time back. So I don't know how I came up with this choice of cluster representatives, the cross in this diagram. But once I know that there are three clusters, so K is equal to 3 was fixed. This decision variable was fixed. These decision variables were fixed, Z1, Z2, Z3. Then once these 4 decision variables are fixed, now I have C1 up to C100 and I have to make the best possible choice of C1 up to C100. So what do I mean by making the best possible choice of the numbers C1 up to C100? I want to minimize this J cluster objective, right? I want to minimize this distance. So in this particular case, K is equal to 3 for the sake of understanding. Z1, Z2, Z3 is already known. And then I want to minimize this sum of squares. Okay, now if you look at this sum of squares carefully, then you see each of these terms. So C1 plays role only in one of these terms. Which term? The first term. So if you take a value of C1, the only thing that changes in this clustering objective is the first term. No other term is changed. No other term is reflected by varying value of C1. Why? Because what is the value of C1 will determine what is the value of ZC1, and that will determine what is the value of norm of x1 minus ZC1 square. So for example, in this particular case, if I take C1 is equal to 1, so if I take C1 is equal to 1, then I have x1 minus Z1 whole square. If I take C1 is equal to 2, then I will have x1 minus Z2 whole square. And if I take C1 is equal to 3, then I take x1 minus Z3 whole square. And in order to minimize this clustering objective, when I vary C1, the only term that is changing is first term in the sum of squares, and I will choose the minimum amongst them. So what am I really doing? I am going to choose the nearest neighbor. I am going to choose the nearest neighbors amongst the cluster representatives to x1, and I am going to assign x1 to that particular cluster. If I do that, what happens to the clustering objective? What happens to the clustering objective is amongst all possible values that this first term in sum of squares take, you will have the minimum possible value. I do the same exercise by varying C2 now. When I vary C2, the only term that is affected in sum of squares is the second term. I do the same thing. I substitute C2 is equal to 1, C2 is equal to 2, and C2 is equal to 3. I find out difference between x2 minus Z1, x2 minus Z2, x2 minus Z3, and I see what is the minimum distance. So in this particular diagram, what I'm doing practically, what I'm really doing is I am finding nearest neighbor of x2 in from these 3 cluster representatives, and whatever is the nearest neighbor, I assign that cluster to x2 and so on and so forth. And I do this exercise for all of this capital N number of data points in the data set that is given to me. If I do that, then I think, do you all agree that I have done the optimal cluster assignment in this particular case? I have fixed K, I have fixed cluster representatives. So how I fix cluster representatives, I don't know. So for example, I could have fixed the cluster representatives in this particular way as well, and you cannot really say no to it. So for example, I could have fixed these 3 cluster representatives as well. So when I did these 3 cluster representatives, the 3 green stars, then I can do the cluster assignment based on these 3 also. So these 3 also are allowed, and then I will get a different type of cluster assignment, different clustering. So how do I come up with this cluster representative? We are not saying it yet. But if you have a choice of cluster representative, then this C1, C2, Cn assignment that you do in order to obtain the best possible clustering assignment by minimizing this clustering objective J cluster. So I hope this part is clear. So what I'm really going to do is I am going to understand how this clustering objective behaves with respect to different types of decision variables. So I have fixed K, I have made choice of cluster representatives, and then I will do this assignment. The next thing that I do is I have fixed K, I will fix the cluster assignment, and then I will see what is the best choice for cluster representative. So I will see how J cluster behaves with respect to varying this, and then finally we'll see how when you vary K, the clustering objective changes, and then based on all these 3 things together, we'll come up with an iterative scheme which is called as K-means clustering to approximately minimize this J clustering objective and come up with the clustering algorithm. So I hope the plan is clear. At this point now, if you have any doubts, you can ask me. So I think somebody was asking about minimizing the J cluster. So is the plan clear what we are going to do? Somebody was asking at the beginning of the class. I hope.
Yes, sir.
Yeah, this answers the doubt, right?
Yes, sir.
Okay. So anybody else, if you have any doubts or comments, I think this is best time to sort of pause and make sure that everybody is on the same page. Anybody wants to add anything, please go ahead.
Hello.
Uh,
Sir, am I
yes.
audible?
Yes, yes.
Sir, sir, I'm confused with the ZC1. Like how we choose ZC1,
So that's what
ZC1
I'm
and ZC2.
saying. In the first place, the way I have described it so far, I have not told you how to choose ZC1. I'm just telling you how the cost function or the clustering objective behaves with respect to different set of these decision variables. That's what we are doing. Okay, so I
Okay.
have fixed Z1, Z2, Zk. How I make a choice of Z1, Z2, Zk, I have not yet told. But for a given choice of Z1, Z2, Zk, how can you see the clustering objective? How does it behave with respect to this C1, C2, Ck, and how can you come up with best possible assignment for the clusters? So that's what I have told you. The same thing I will do once we write this thing down that we have discussed so far. I will fix K, I will fix the cluster assignment, and I will tell you what might be the best choice for cluster representative. That's what I will do.
Yes, sir.
Yeah. So that's the next step. So is that okay? Anybody else? Okay, so let's write down. Let's start writing down what we have discussed so far. So let x1. So let z1, z2, zk be the group. So behavior of j cluster with respect to different decision variables. Okay, so that's what we are going to do. So what we do, we fix k, number of clusters, and we fix z1 up to zk, cluster representatives. Okay, so these are the two things that we fix, and now we want to make. So choose C1, C2 up to Cn best clustering assignment so that J cluster is minimized. Right? That's what we want to do. And in order to do so, what we observe. So what we observe is the following. Observe when we want to minimize J cluster with respect to this C1 up to Cn. So this is the objective now that we have. This is same as minimizing with respect to C1 up to Cn x1 minus zc1 square plus x2 minus zc2 square plus so on so forth x capital N minus zcn
Sir, you are not audible.
Hello. Am I audible?
Yes, sir.
Hello.
Yes, sir. You are audible.
Yes, sir.
Yeah,
audible.
the thing is, there is a power cut here, so the power has just restored. So let me restart everything again. So it will take a couple of minutes time to restart everything again. Okay, give me 2 minutes. I will be online in 2 minutes time.
Sir, you are muted, sir.
Yeah. So about 100 of you are still here. I am very thankful for you. uh, there was a problem and there was a power cut, so because of Wi-Fi the router power went off and everything went off, so hopefully now it will be all right. So let me see if I can join again from my, looks like you're offline. Okay, so just give me a minute. I will restart this thing. And so did you get my message that there was a power cut and I am offline because of that?
Yes, sir.
Okay, so at least that thing was working. Okay, so in the meantime, when this thing is okay, this thing is starting now. So I have realized that there are several meetings. Somebody was complaining yesterday that there are several meetings that start because of this. I don't know how many meetings start. So it was pointed out in one of the Facebook groups that any student, when they join, they start a meeting rather than joining the meeting that was already sent. So because everybody starts a meeting, there are many meetings that are in progress at a given time. And then I was told that students are required to go in every meeting and then check what is really happening. So my request is that maybe what we can do is I will log in 5 minutes before the class time, and there'll be one meeting that I will start, and maybe you all join only that meeting which I have started. So for students, the request is don't start meeting on your own, because then that will be a really very difficult thing. Okay, so I think there are so many disturbances today. There is I think no point recording this. I will record this K-means clustering lecture entirely, and I will share the video with you. So I think that is something that we can do today. So